We've seen that MATLAB's pretty picky about its rules. Every programming language is. The reason is that strict rules make it easier to write accurate, unambiguous programs. We've violated MATLAB's rules several times, and we've seen those red error messages that they cause. There's a computer science term for this type of rule. The type of rule we've tripped over, it's called syntax. Syntax is a language's set of rules for the form of the statements, including, for example, the rule that says you can't use a hash symbol in a variable name. Here's another example.
1 equals x. Of course, MATLAB doesn't like that. As you can see, it says the expression to the left of the equal sign is not a valid target for an assignment. The simple form of this syntax rule, or syntactic rule, that we're violating is this. In an assignment statement, there must be a variable name on the left of the equal sign. We knew that, and we know that 1 is not a variable name.
We'll run into lots more syntax errors as we learn more rules, but there's another type of error that is much worse, the semantics error. As we said, the syntax of a command is its form. The semantics of a command is its meaning. An example of semantics is this.
Suppose we want to swap the values that are in x and y. First, note that the current value of x is 42 and the current value of y is 87. I've seen many new programmers try to do it like this. And by the way, I'm certain I did it too when I was starting out. So I type x equals y and y equals x. You see what went wrong here? Let's look up here and see that something did go wrong. They're both equal 87. Instead of having their values swapped, they both now have the value that y had before. So what happened? Well, the first statement, this one here, copied the 87 that was in y into x. And at this point, they both have the value 87. So x's value has just been lost. 42 is gone. Then this next statement just copies whatever's in x, which happens to be 87 now, back into y. So y is 87, it was 87, that really didn't do anything. Well, let's do it right. First, let's set things up the way they were to begin with. X was equal to 42, and y was equal to 87. And we can see that we've done that over here in the workspace. Now here's how you swap them. Temp equals x. We've copied x into temp. Temp stands for temporary variable. We've actually saved it there so that when we copy y into x, we haven't lost x's value. And now we simply copy temp into y. And there we go. So when we made the error, MATLAB didn't catch it, and it didn't print an error message, and there wasn't any red color. That's because our syntax was perfect. The problem is that our code didn't mean what we thought it did. This is a semantic error, also known as an error of semantics. The semantics of our first try was that y's value was simply copied into x, that's all. It was a semantic error because we thought that x's value would also be copied into y. A semantic error is an error in which the meaning of our code is not what we intended. And the reason that it's worse than a syntactic error is that MATLAB has no way of knowing that it's an error. Neither would the other languages we've talked about. We could have made this particular error in any one of thousands of applications because swapping variables is a generic problem and occurs a lot. But an even more common type of semantic error is one that is application specific. Look, for example, at the formula we use for calculating absolute zero in degrees Fahrenheit. Right up here. It's correct, but suppose we'd typed this. Everything's the same, except that we used a minus instead of a plus.